In the companion video, you saw how IBM StreamSets could quickly build a real-time pipeline to manage the movements of one truck in the supply chain. However, if we need to track hundreds of trucks and hundreds of items, there is a faster and more efficient way to scale this solution using the StreamSets SDK for Python. Before we get started with the SDK, let's recap what we built in the previous video using the StreamSets UI. We subscribed to an MQTT stream of truck telemetry data from our supplier. Then we enriched the data with traffic and weather data. A new field was created that calculated the delay risk, and then we put this streaming data into Elasticsearch for visualization and alerting. For this scenario, we are going to track multiple trucks that are all publishing data to a different MQTT topic. We'll duplicate our existing pipeline and create multiple versions with each subscribing to a different topic. Finally, when we have all the pipelines created, we'll create jobs for each of them. Let's get started. Step 1 is to duplicate the existing pipeline. We will take a copy of our original pipeline, and we just call sch.pipeline.get and use the name of our original pipeline. Let's click Run, and this will duplicate the pipeline. We're going to make 5 copies, but you can make as many copies as you want. If you were tracking 100 trucks, you could make 100 copies. We'll click Run and go back to Control Hub where we see that 5 copies of the pipeline are being created. If we wait a few seconds, we see the first 2 have been created. While we wait, we'll go back to our code and start Step 2 to iteratively update the pipelines with new MQTT topics. And how do we do that? First, we will loop through the set of new pipelines that we created and then set new pipe, which is just the instance of the new pipelines that we're working with. And we're going to set the configuration of the topic filter. We're looking at this new pipe, and we're looking at the 0 stage, which is the MQTT subscriber stage. Then we're looking at the configuration, and we're changing the topic filter. The topics are all logistics/truck telemetry plus a counter. This would be truck telemetry 1, then followed by truck telemetry 2 or 3 or 4, and so on up to the number of copies specified in the previous step. Last, we'll go ahead and publish these changes to our Control Hub by using sch publish pipeline, and we're going to publish this new pipeline. Before we run this code, let's go back and check our pipelines. You can see that we now have pipelines 1, 2, 3, 4, and 5. But when we click into the pipelines, we see that our MQTT subscriber topic is still logistics/truck telemetry, and that is the same for all these pipelines since they were just duplicates. After we run this code, all of that will change. So let's go ahead and run this block. After a few seconds, we can go back into Control Hub to see the changes. Let's click on Pipeline 1 and we should see that the topic is now logistics/truck telemetry 1. And for the second pipeline, we see a topic filter of logistics/truck telemetry 2. This pattern will continue for as many copies as we created in the SDK. Now the third step is to programmatically execute a job for the pipelines that we have created. What does that look like? Let's first create an empty job list so we can keep track of the jobs or for metric collection. And then for each of the pipelines in this new pipeline list that we created originally, we are going to create a job builder. This just prepares the pipeline for job execution. Then we are going to build a job. We'll call it logistics demo plus whatever the new pipeline's name is. And then we're going to add a data collector label, which essentially tells the data collector which engine to use based off the label. Our label is MQTT, and the next step is to add a job. And then start the job. And then lastly, we want to append the job to this empty job list here. At this point, we have completed all the necessary tasks, but we are going to add a few more blocks of code for cleanup. This job will run for 3 minutes and then stop. You could create a Step 4 with simple codes to programmatically collect the metrics for the jobs and then analyze the performance or the throughput of the jobs that were executed. How many delay risks were there? What was the throughput of each of the jobs that were executed? And so on. But in this case, we will run the script here. Back in Control Hub, we see that each of the pipelines will have a job created and started. We see a job for pipeline copy 1. And a job for pipeline copy 2, and for pipeline copy 3. All the jobs will be created for each pipeline we created. Once these jobs run for 3 minutes, which is what we configured, it will go ahead and stop and close all those jobs just for cleanup purposes. With just a few lines of code, we were able to iteratively duplicate the pipeline that we created in our UI, make changes to the topic filter and execute jobs for all the pipelines that we created. Using the SDK for Python, we can save a lot of time when creating, editing, and running pipelines at scale. Would you like to see how IBM StreamSets can take your manufacturing and logistics operations to the next level? Contact us for a live customized demo and a free trial of the software. Thank you for watching.